Today we're going to do 4.1 Introduction to Triangles. In this foldable, we'll start with the Classified tab, and we'll do the triangle sum theorem, and we'll leave exterior angle theorem until tomorrow. All right, so open up your flap that says Classify. That's where you're going to see a triangle is, and we're going to give a definition here. What is a triangle? A triangle is a polygon with 3 sides. Okay, so it's a polygon with 3 sides. We know that the triangle can look many different ways, but these are 3 different ways that you could possibly see your triangles. It has 3 sides. Okay, when I say classify a triangle by the sides, this is what I want you to do, okay? So, if you have a side where all of the, if you have a triangle where all of the sides have different sizes, this is what we called scalene. And that triangle that we see below, where I'm writing scalene, that is an example of a triangle with different side lengths, okay? So how would that look like with markings? So I would say that this side has 1 mark, this other side has 2 marks, and this other side has 3 marks. Different markings, it tells you that the sides have different measure, okay? If you see the same amount of markings for each side, then that tells you that those sides are equal, congruent, same measure, okay? But in this case, scalene just means no congruent sides, no equal sides. They're all different. Ok, para esta unidad vamos a estar hablando de triángulos. Vamos a empezar con la definición de un triángulo, que es un polígono con 3 lados, ¿ok? Vamos a clasificar los triángulos por los lados primero, ¿ok? So, cuando yo les digo clasifíquenme el triángulo basado de los lados, van a ver 3 diferentes tipos de clasificaciones que podemos hacer. La primera que vemos se llama scalene, donde los lados de tu triángulo tienen diferentes medidas, ¿ok? Y las marquitas, como son a diferente cantidad de marquitas, quiere decir que también el largor de los lados del triángulo son de cantidad diferente, ¿ok? So no hay ningún lado que sean igual, congruente, ¿ok? So esa es la primera, scalene. Y el segundo triángulo que vemos ahí se va a llamar isosceles. So the second triangle that we have here is going to be called isosceles. Let me get my pen ready. Isosceles. Okay, and it means you have 2 congruent sides. Okay, how would this look with the markings? Let's say that this side and this side have the same measure. Well, they'll have 1 marking each, okay? And the third side, we could just add 1 more marking, making it different, okay? So 2 of the sides has 1 marking, and the third side has 2 markings, saying it's different than the rest of the sides. Okay, so there's only 2 sides with equal measure. Like, for example, we could say that this is 5 meters. So then because this one has the same markings, it's congruent. It's also 5 meters. And the other one, we could say it's 10. It could be different sizes. Ok, en este triángulo isósceles hay 2 lados del triángulo que tienen la misma medida. So, yo el lado que decidí que tiene la misma medida, tiene una marquita cada lado. Acuérdense que la cantidad de marquitas que son similares son las partes que son iguales o tienen la misma medida. So, yo veo que este lado, necesito mi otro plumón, este lado y este lado cada parte tiene una marquita. Esos dos lados son congruentes, tienen la misma medida de 5 metros. El otro lado, que está aquí en azulito, tiene dos marquitas diferenciándolo con los otros lados y tiene una medida de 10 metros. Ok, last one. So, la última parte aquí, definición, es equilateral. Ok, equilateral, hay tres lados que son congruentes. Pongo la marquita que dice congruente en vez de escribirlo todo. Ok, equilateral means three congruent sides. So all the sides are congruent. They're equal in measure. So I could say this one's the same as this one and the same as this one. And so we could say that they are all 5 meters. They're all the same size. Ok, equilateral quiere decir todos los tres lados tienen la misma medida y por eso vemos una marquita para cada lado. Ok, yo me voy a estar como que moviendo un poquito en mi plataforma, pero ustedes van a seguir escribiendo ahí abajito. Ok. Dice clasifica. Classify a triangle by its angles. So vamos a seguir clasificando, pero esta vez por los ángulos. Okay, so when I say classify by the angles, not the sides anymore. We're not looking at the sides, we're looking at the angles. The first one that I'm going to talk about is acute. Okay, so when I say a triangle is acute, that means that all of the angles in this triangle have acute angles. They are less than 90 degrees. So I'm going to put angles less, can't spell, less than 90 degrees. So for example, we could say this one is 40 degrees. This one is 60 degrees. And that this one is 80 degrees. They are all less than 90 degrees. They are all acute. So all the three angles, so I'm putting my symbol for angles, are acute. Ok, para un triángulo que se diga que es un triángulo acute, en español agudo, los tres ángulos tienen una medida menos de 90 grados, ¿ok? Y cuando agregas tus lados te va a dar una medida de 180, ¿ok? Pero lo importante de aquí es que los ángulos, los tres ángulos de este triángulo tengan menos de 90 grados. Por eso tengo uno que es 40, otro que es 60, otro que es 80. Con que los tres sean a menos de 90 grados, podemos decir que el triángulo es agudo, acute. Okay, next part. For the next definition, we're going to say that this is an obtuse triangle. Okay, so one of the angles has to at least be obtuse. So one angle has to be obtuse. Okay, so what do I mean by that? Well, one of the angles has to be greater than 90 degrees. Okay, so obtuse means greater than 90 degrees. Greater than, bigger than. Okay, so I can say that this angle at the top is my, this angle at the top is my obtuse angle, and it's, let's say, 120 degrees. Just one of them has to be greater than 90, and we can call this triangle obtuse. Ok, con mi triángulo obtuso, el uno de los ángulos tiene que tener una medida de más de 90 grados para decir que es un triángulo obtuso. So, yo en mi dibujito puse que el ángulo de arriba es el ángulo que es obtuso porque es de 120 grados. Más grande de 90 grados se dice obtuso. ¿Okay? No tienen que ser todos los tres ángulos más de 90 grados. Aunque uno sea más de 90 grados, se puede decir que el triángulo es obtuso. Okay, and let's do this last part here. The right triangle is the last one. So this is the right triangle. Okay, so we know it's a right triangle because a lot of the times we see that little box in one of the corners that forms kind of like an L. So at least one of the angles has to be right. So one, that's one. One angle has to be right. Okay. So, un ángulo solamente en este triángulo tiene que ser 90 grados para poder decir que tengo un triángulo right, derecho, ¿ok? Right triangle. One angle only has to be right. Solamente uno de esos ángulos tiene que ser 90 grados, ¿ok? Muchas de las veces sabemos que es un right triangle porque tenemos esa cajita en una de las esquinas. Okay, vamos a seguir. Let's keep going. What is an equiangular triangle? So another definition. An equiangular triangle is a triangle with three congruent angles. I think also the sides are similar, are the same if we have three congruent angles. So we could say that this angle is the same as this angle, like this angle. So they are all 60 degrees. Remember, in a triangle, you add up all the angles and they should give you 180 degrees. So if they are all congruent, the only option is that each angle in this triangle will be 60 degrees each, okay? Okay, con un triángulo equiangular es cuando el triángulo tiene los tres ángulos iguales, congruentes. Acuérdense que congruent, es igual, equal. So, yo también sé que en un triángulo, cuando agregas los tres ángulos juntos, te tiene que dar siempre una medida de 180 grados, ¿ok? Entonces, si los tres ángulos son iguales, tienen la misma medida, la única alternativa es que a cada ángulo de este triángulo sea 60 grados, ¿ok? 60, 60, 60, y eso se llama un equiangular triangle. Es un triángulo especial. Okay, I'm gonna keep going. Okay, with the triangle sum theorem, I'm going to look at something that I kind of mentioned earlier. You're adding all of the three angles together and it should give you a measure of 180 degrees. So when I fill this in, it should say all three angles in a triangle add up to be 180 degrees. Okay, so we have angle 1, angle 2, and then angle 3. And maybe I should put arcs to signify the three angles. That kind of distinguishes angles. So I could say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 gives me, or should give me, 180 degree total. Ok, so la teoría de la suma del triángulo, donde agregas todos los ángulos, todos los tres ángulos se agregan y te debe de dar una medida de 180 grados siempre, ok. So, la medida de ángulo 1 más la medida de ángulo 2 más la medida de ángulo 3 es igual a 180. Vamos a hacer unos ejemplos para ver cómo nos presentaría esto en un examen, okay? Examples of triangle sum theorem, find missing angle. I'm going to look for the missing angle. This is something that I would possibly give you in a quiz or a test, okay? Let's start with the first example. I have my triangle here. I know that one of the angles is 23. The other one, I don't know directly what it is. It didn't tell me, but because of this little box here, okay, I know it's 90 degrees. The third one is the one that I'm looking for, so I'm going to put my question mark there. So this is just common sense, okay? So I know that if I add all three angles together, I should get 180. I know two of them, so to get the third angle, I'm going to subtract. So I'm going to go ahead and add 90 plus 23, the two that I do know, and use your calculator, but it should be 113 degrees. I'm going to grab 180, and I'm going to subtract the two that I do know, which is a sum of 113. Do the subtraction in your calculator. You should be getting a total of 67 degrees. So that means this angle is 67 degrees. Ok, para buscar el ángulo que no sabemos o el tercer ángulo, primero vi lo que tenía en este triángulo. Uno de los ángulos es 23, el otro es 90 grados. No me lo dice directamente que es 90 grados, pero el símbolo de la cajita me dice que ese ángulo es 90 grados. ¿Okay? Para buscar el tercer ángulo, voy a hacer algo que es common sense, es muy común. Agregas los dos que sí sabes para restarlo con 180, porque así te va a dar la medida de lo que debe de ser ese tercer ángulo, ¿ok? Eso fue lo que hice, 90 más 23. Usen su calculadora, por favor, pero debe de ser 113. Lo resté con 180 y me dio mi medida de 67 grados. Entonces, esa marquita que pongo después de mi número, de mi respuesta, esa marquita que quiere decir grados. Degrees en inglés. Voy a hacer algo muy similar en el próximo problema. I will do something very similar to what I just did in this other problem. I know that one is 40, the other one is 50, and I'm looking for the third angle. So I'm going to add the two that I do know. So 50 plus 40 gives you 90 degrees. I'll do 180 minus 90, and I should get 90 degrees. So this one is 90 degrees. All right, so that's the theory of the sum, the triangle sum, okay? How would it look like if I had variables, if I had expressions representing angles? Well, let's kind of look at that, okay? For number one, it says find the value of x. Okay, so that's what we're looking for first, finding the value of x. So vamos a encontrar el valor de x ahorita y ahorita no tenemos números representando solamente el ángulo, ahora tenemos expresiones. Uno de los ángulos va a representar expresiones y tenemos que buscar el valor de x. Eso es lo primero que me pregunta en mi problema. Okay, so one of the angles is going to be 8x minus 2. This other angle is 8x minus 2. And then the third angle is 7x, okay? Those are representing the angles instead of numbers right now. But the same thing applies. Remember that each angle added together should give you 180. Because I know that fact, that's what I'm going to use so I can figure out what is that x value. Okay, because that's what I'm doing, finding the value of x right now. So I'm going to grab 8x minus 2, and I'm going to add it with 8x minus 2, the other expression, and I'm going to add it with the third expression, which is 7x. Okay, so I grabbed each angle, each part, each expression. I'm adding them together, and I'm going to put it all equal to 180 degrees. Ok, so estoy agarrando cada ángulo. Okay, uno de los ángulos representa 8x menos 2. El otro ángulo también es 8x menos 2. Y el tercer ángulo es 7x. Cada parte del ángulo lo estoy agregando y lo estoy poniendo igual a 180, ¿ok? Ok, acuérdense, cada parte agregada me da 180 y estoy usando esa teoría de la suma del triángulo. Ok, y entonces voy a empezar a trabajar con mi ecuación, a combinar lo que puedo combinar y tratar de resolver por X. All right, so I know that I'm going to have to combine like terms on the left side. So I'm going to combine all of the x's together. The ones in blue are all x's. I'm adding all of those together in just a bit. -2 and -2 are two that I can combine as well. Okay, so let's do the blue part first. 8x plus 8x plus 7x. If you put this in your calculator, it should give you 23x. And -2 plus -2, put it in your calculator, but it should give you -4. Okay. So again, I didn't use my calculator, but you could use your calculator, and I'll show you. I'll get what I need here for each part. So 8 plus 8 plus 7, that's how I'm getting that 23. If I do -2 plus -2, I get that -4. That's how I'm getting -4, that -4. Okay, and then it's equal, bring down the 180 degrees. Okay, so I need to solve for x like normal. All I have to do is make sure that x's are all by itself on the left side. So that -4 shouldn't be there. I'm going to add 4 on each side. So it's 23x equals 184. Okay, almost there. I don't want to know 23x. I want to know what just one of the x's would be equal to. So to get 1x, I have to undo this 23 that's multiplying with x. So I'll divide by 23, and I have to divide by 23 in the other part. So x is left by itself. Let's bring out our calculator. Let's drag it in. 184 divided by 23. 184, 180, 180, what's happening? Can't move it. 180, I have to move it a little bit to the side because if not, I'm not going to be able to. 184 divided by 23. See what I get. And I got an even 8, which is nice. So your x equals 8. They only asked for x, so I can stop there. Ok, cuando yo agregué cada parte del ángulo, cada expresión las agregué juntas, las puse igual a 180, formé mi ecuación. Ahora es nomás de combinar en la izquierda todo lo que es similar. So yo combiné 8 y 8 y 7 porque son los que contienen x. So combiné todos los x juntos y voy a combinar todos los números juntos. So -2 más -2, pónganlo en su calculadora, pero debe de ser -4. Ok, so 23x menos 4 es igual a 180. Aquí la meta es que x esté solo en un lado. So muevo lo que estorba. Ese -4 no tenía que estar ahí. Agregué 4 en los dos lados. Bajé todo. Y luego mi último paso fue dividir por 23. Y me dio un resultado que x es igual a 8. Ok, el último problema en esta parte del día de hoy. Mañana terminamos lo demás. Pero número 2 me pide cuál es la medida de ángulo ACB y cuál es la medida de ángulo BAC. Que voy a hacer algo muy similar, lo que acabo de hacer, en agregando cada parte. Pero al último, no nomás es de resolver por X, me tengo que regresar a ver cuál es la medida de cada parte, okay? So for number 2, find the measure of angle ACB and BCA and BACA. Oh my God. And the measure of angle BAC. Okay, so those are the two that I'm looking for. So ACB is this one right here, and BAC is this one right here, that angle right there. Okay, and then the other angle, angle B, the one with the box, remember that one's 90 degrees. I'm going to fill it in. Okay, so I'm going to do very similar on what I did earlier. I'm going to add each part and then put it equal to 180. So I'm using the triangle sum theorem. Okay, I'm grabbing each expression, each part of the angle, adding it together, putting it equal to 180. So I'm going to grab 3x minus 7, and I'm going to add it with the other part, which is 4x plus 6, and then I'm going to add it to 90, and then I'm going to put it equal to 180 degrees. Okay, so 3x, 4x are the only parts that I can combine that contain x's. And then I have negative 7 plus 6 and 90, then it can be combined. So 3x plus 4x, 7x. Right, use your calculator. Negative 7 plus 6 plus 90. Okay, that one, since it's a little bit harder, I am going to pull in my calculator and see what it is. Let me see. Okay, so I'll put it right there on the side. I know I need to plug in my numbers. Let me do that. So it's 3. Oh, I can't. There we go. So can't write. Can I? Okay, it's the way that I have this dragged in here. I may need to. Oh my gosh. Hold on. It's not moving at all. Okay, I think I need to move this out of the way a little. Okay, maybe now I can do it. Okay, maybe I can't. There we go. Sorry, sometimes I have technical difficulties and I need to adjust. So 3 plus 4. Oh, sorry, no, I'm not doing those. I already did that. Oops. Okay, so negative 7. So I'm doing the numbers right now in blue. Negative 7 plus 6 plus 90. Okay, so I didn't really want to do it in my head, but I got 89 with my calculator. Great. So it's a positive, so plus 89. So the 7x is going to be added with 89, and it should be equal to 180. I don't know. I think it 108 when I wrote it down. Okay, so this is what you should have so far. Again, you're just combining like terms to the left and kind of trying now to solve for x. So again, x should be by itself. I'm going to move that 89, so I do the opposite. Subtract 89, subtract 89. We have 7x equals. So with this one, a 180 minus 89 should be 91, right? Okay, so the last thing to do is divide by 7 and see what we get with our calculator. Okay, now when we do this in our calculator, it should give me 13. It's going to give me a nice even number. Sorry, not even, but it's odd. But it's a nice number, you know. No fractions. Okay, so x equals 13. Now, that's important. But the question was, find the measure of angle ACB and the measure of angle BAC. So I have to go back still and plug it in, okay? I'm going to find each angle first that I need. The red one and the blue angle. So x is 13. I'm going to put that at the top. X equals 13. Remember that. Now, one of the angles represents 4x plus 6. So I'm going to just plug it in. Take out x, plug in 13. So 4 times 13 plus 6. Again, use your calculator as much as you can. But when you do this, you should get 58 degrees. So this angle is 58 degrees. So the measure of angle BAC is 58 degrees. Okay, I'm going to do very similar what I just did with measure angle ACB. Oh, sorry, I did something crazy. I said this is BAC, but this angle is actually ACB, the one that we were supposed to find at first. Sorry, I don't know. It's late. So just kind of recheck that you're doing correctly. Measure angle ACB is what we're dealing with for the red one, and it's equal to 58. Okay, measure angle BAC, the one in blue, is 3x minus 7. So again, take out x, plug in that 13 that you got, and put it in your calculator exactly how you see it with parentheses and everything, and you should be able to get an angle of 32. So this angle is 32. All right. You have an exit ticket that you're going to do, and it should kind of give you an idea of your kind of understanding how to put everything together. And then tomorrow we'll finish the last part of the foldable, okay? Good luck. Voy a parar el video aquí, pero todavía hay que hacer la última parte mañana, ¿ok? Van a hacer una práctica en una hojita para ver qué es lo que están entendiendo. Y mañana seguimos practicando. Buena suerte.